This is the machine as it sits. You can see the form made there from Aluminite Vac 50. Actually, that has been cast from a form which we made from a CNC routed plug. And you see the vacuum table. Next up is a slotted framework that's on rollers that the framework with the plastic goes in, and then the overhood for the overpressure in addition to the vacuum. So the idea will be to bring the sheet out of the oven, flip it 180 degrees, slide it in, take it down onto the vacuum table, turn on the vacuum, then lower the top hood down and add the air pressure through the valve there to give it some additional pressure differential. This is just a little Hamilton Beach toaster oven, modified. You see a sheet of rock wool laying on top of it. We'll take that and put that on the inside of the cover. We will retain, however, the convection fan to make sure that operates. That makes a big difference in the way the plastic heats up evenly. A little background on the little toaster oven that we're using. It's been hot rodded a little bit, and that we've added a 1/4 inch aluminum plate above the heating elements on the bottom as well as on the top to keep some of the direct heat from coming in and spread it out over the entire interior. You can see the milky white appearance of the high impact acrylic that we're using, and you see the steel frame just starting to get a little bit of deflection in the sheet after 30 minutes at about 200 to dry it out some, and 10 minutes at 350. I just took it to 375, and you see the sandwich of the steel framework, then the plastic, and then the aluminum framework that the N52 magnets are embedded in. And so what we're looking for is about 3 inches of sag until we're ready to transfer it over to the machine. I'm really pleased so far with the way the magnets are holding down the edges of the high density acrylic, because that stuff really wants to warp and deform once it starts heating and sagging. You can see we're just starting to get enough sag there to where it would really be lifting that up if it weren't held down properly. We'll just get a quick shot here of the temp gun, and you can see the transmissivity of the plastic is about 100 degrees less than what the oven temperature is set at. I wouldn't certify off on that oven temperature either, but it's somewhere between 300 and 400 degrees. Very difficult to see here, but the material is beginning to visibly sag as you watch. At 425 degrees, it's just stabilized there, so I will go set up the next shot, and hopefully the next time I come into frame will be to show the insertion of the material and the forming.
Ooh, that is hot. Come on, baby, get in there. All the way back to the back.
think we probably should have let her get a little bit hotter before we brought her on. Cool down here. That sound should have been just it popping free from the surface of the mold. Very, very close for a first try. I don't know if it's quite cool enough yet, so I'll hose it down a little bit with some air and we'll see if we can demold it and see what we get out. There we have it. And we'll cut that out and see what it looks like. And there's the final result. You can see a blemish right there. And some minor blemishes there. And there's a blemish there, and a blemish there. Those are all from small pockets in the surface of the mold that when the air heated up kind of blew up like balloons. So they'll get filled in with the VAC 50 and slicked back down, and I'm pretty happy with the way that came out the first use on this stuff. It's a mold that's unseasoned and get apart that nice all first time. Not too bad. The imperfections look considerably worse on video than they do in actuality, which is nice for a change because they look like little magnifying glasses. So, pretty happy with that.